Welcome back to the Python Fundamentals tutorial. And today we're going to be looking at an example of a problem that we can use to apply all the list methods that we've learned so far. So these values that are in the list should be in the description, and you can copy and paste them if you want to use the same exact values that I'll be using in this video. Otherwise, you can just put in whatever random numbers you want as long as they are numbers. I encourage all of you to try this on your own and try to see how far you can get without referencing the video. And whenever you get stuck, you can obviously start watching the video. So without further ado, we can just get started. A class of students takes a test with scores that should range from 0 to 100. It's clear that someone has tampered with the results and gave some negative scores, and scores above 100. Remove these false values. So we can see we have negative 87, negative 10, 200, and 337, right? So these are scores that students shouldn't be able to get. So to fix that, we can loop through the list and check if each value is reasonable, right? So we're going to use a for loop, right? So for each score in testScores, if the score is negative, right, less than 0, or it's greater than 100, right? So it's obviously been tampered with. Then we're going to use testScores dot remove. And remember that the dot remove looks for the first value in the list that it finds, that like whatever's in the parentheses, and it gets rid of it. So we can remove the score, right? So if the score is negative or greater than 100, it's going to look through and look for that specific number and take it out, right? Now we can check our work by doing print test scores, and we run it, and we can see all the test scores are reasonable numbers, none of them are negative, and they're all less than 100 or equal to it. Now the next task they give us is to find the highest and lowest score on the test. Now the easiest way to do this is to look for McAfee. Alright, now the easiest way to do this is to sort the list and look at the first and last values. So testScores dot sort, right? So if we sort this, it'll put it from the least greatest value to the greatest value, right? So if we print testScores 0, right, this will give us the lowest value, right? Because if it's in ascending order, then the first value will be the lowest in the entire list, right? Likewise, the last value will be the highest in the list. But how do we access the last value? Well, if you recall, if I plug in -1, that will give me the last value in the list, right? So we can run that, and we can see that the lowest score was a 32 and the highest was 100. You can visually check that by just looking at the list. Now we're asked to find the average test score. So the average is the sum of all the things in a data set divided by the number of entries in that data set, right? So you're going to need two variables to keep track of what we're counting as we're going through the test scores, right? Because we're never given the number of test takers that there are. So we're going to find it ourselves. So we're going to set the sum equal to 0 and the number of test takers equal to 0, right? Because we're going to add to both these numbers. Now we're going to loop through the list again, right? So for each score in testScores, right, we're going to add whatever score it is, right? So sum plus score. So we're going through, and for each score, we're going to add it to whatever we have in the sum. And this is just going to get us the sum of all the values, right? And then test takers plus equals 1, right? So for each score, we're adding 1 to the variable test takers, which is at the end going to be the value of the number of people who took the test, right? So we can see from that the average is going to be the sum divided by test takers, right? And to check our work, we can just print average, and when we run that, we get 75 and 18, or 75.18 repeating, right? So that's just the average of the scores that are valid. Remember, we took out all the negative and over 100 answers. Another class takes the exam, and their scores are as follows. And we can see that all their scores are set in a list called nextClass. Now we have to create a new list that contains all of the updated values and sort the list, right? So this new list is going to contain all the test scores from both of the classes, right? So we can call it finalized list. And to join the two lists, I'm going to do test scores plus next class, right? So this is just going to put test scores, which is already sorted for us, in and then put it with all the values in next class right after it, right? So we need to sort the list, so I can just call finalize list dot sort. Now we have a sorted value for all of the finalized list, right? Run that. And we can see that all the test scores from both of the classes are here in ascending order. Okay, so the teacher curves the test by 5 points, adding 5 to every test score. Print out the new scores in ascending order, and these scores can be greater than 100. So I can do this by using a for loop, and it will take a few lines of code. But if you notice, I can also use list comprehension to solve this problem, right? So we're going to do print, and then when we're using list comprehension, we have to use square brackets. Now, what are we returning? So think about it. If we want the score, but it's curved by 5 points, we just do score plus 5. This is going to return every score on the list and add 5 to it. Now we put in our for loop for score in finalized scores. So this is going to go through every single value, and it will print 5 plus that. Oh. And we can see that it's the same list, it's just that every single value is 5 more because of that nice curve. So now it's asking us to take the average of the finalized list and state the difference between the previous average without the curve. So this part kind of saves us because when we do list comprehension and we're returning score plus 5, we're not actually changing the values in finalized list. We're just returning the value score and then we're performing some operation on it. But that value isn't legitimately or isn't actually changed in the list, right? So this without the curve part makes it a lot easier for us. So again, to take the average, I can just do sum is equal to 0, test takers is equal to 0, and we're basically doing the same thing, except this time it's not in test scores, it's going to be in finalized list, right? Because we're going through all the values between the first and second class. Sum plus equals score, and test takers plus equals 1. The average is the sum divided by the number. Then we can print, and instead of calling this average, I'm going to call it new average, right? Because it's from like all of the values. And it's asking for the difference, right? So we can just do average minus new average, right? And this will just give us a difference between the two averages. And we can see that the average was 7.28 points higher in the first class than it was when we combined their data with the second class. Which is kind of odd because usually the second class does better because they have all the answers from the first class. But that's going to be it for this video, and I encourage you to find more example problems of list methods and try to really apply the knowledge and make sure you know what's going on, because you're going to see lists in everything that you do in Python, and not just Python, in other languages. Arrays, or whatever they're called in their own respective languages, are a really major topic that plays a very important role.